All right. All right, so the recording is back. We have half hour to add a player to record information, right? Wow, this is, I could have just say add a player. What is this add a player to record information on? Yeah. All right, that's some pretty bad that's some pretty bad bad message. All right, add a player to the system. And what we want to do is, as I said, is when we add a player, we want to add a player and the ID of the added player is automatically generated. So we only really prompting for the name of the player, the position of the player, and the date of birth of the player. Okay? The name, the position, the date of birth of the player. And we want to store that in the system. Now remember, I am not doing it here too, but really and truly, your system should make sure that the date of birth is a valid date. How many times have we done that date validation thing? This date validation is one of the most popular validations. So once you have a date being stored on your system, it should validate the data because you want to put that in your test plan later on. That makes sense?
Yeah, sir.
No, all right. So
Yes.
you see, right. So you see, again, it comes like what I was telling you all since the beginning. Everything that we do now has a purpose later on. All right. So this date validation, I'm not going to do it now because I don't think I'll get it done in the little bit of time we have before the end of class. But let's see if we could add a player. So again, we have to go back to our menu and go back to where we call in our functions to add a player. And let's see if we can add player. All right. So we can say void add player. And I know that a lot of our functions looking like they're void and they're not taking in anything, but that is just because of the way that this system is built. All right, maybe, well, we do have one that's taking in an integer. Maybe later on we could come up with something that will return a value if necessary. But still, I mean, we're doing everything in terms of a function and a set amount of code. Okay, and again, this is not the only way to implement this. If you want to pass data between your functions, etc., that is acceptable to do. All right. So void add player, and we're going to call. So we're now going to say add player. Let's continue with the capital P for player. Right. And we will call now add a player inside of here. Okay, so add player inside of here. And I think that we'll get a return value when we do a actual search player function, and maybe even delete player will take in a value as well. Okay, but we're not there yet. We just at add player, and we want to create the add player function. So we go down here and we say void add player. Void add player. And what do we want to do to add the player? The first thing again we do is that we read players. So we read the players, read all of the players into the struct. Why do I want to read all of the players into the struct? This is so that I could find out who in the struct has the highest ID. Because as I said, the struct information should tell me, sorry, adding a player should pass through the struct, read to find out who has the highest ID, and the new player should be, their ID should be the highest ID plus 1. So I could probably have a variable int called highest underscore, or let me just say h underscore ID. I could also have a variable I to search through all of the players read, right? I know that my data inside of here, because I'm dealing with the struct, the ID is an integer. So I can say now, right? So the first thing is to find the highest existing ID number. the highest existing ID number. I say for I is equal to 0, semicolon. I is less than list I, semicolon, I plus plus. So I will look through the existing ID players, players IDs. And what do I want to do, right? I actually don't want to start at position 0. I want to start at position 1 because I will say that H underscore ID is equal to list at position 0 dot ID. So set the first person in the list's ID to the highest ID. Look at that, another concept that we've used before. And then look through the other existing players' IDs to find the highest, right? So if list at position I dot ID is greater than H underscore ID, then it means that H underscore ID is equal to list at position I dot ID. At the end, you add 1 to HID to get the new ID for the player you want to add. So we say that HID plus plus, right? This will be the new person's ID. Doesn't that make logical sense? Test it out. We could say printf, the new person's ID will be %D. And what do we have here? HID, all right? So I just want to test this right now. Get char here. Put a get char there. And say add a player. The new person's ID will be 104. Let's say, for instance, we change this in the file to 107. Let's see if it will work. 1. The new person's ID would be 108. So we're off to a good start because we now know the ID that we want to write for that new person. Where is that new person going to fall in? That new person will fall in at position list underscore I. Because list underscore I does two things. It tells us how many people are currently in the array of players, but it also tells us the position of the next available slot to insert somebody into, right? So we can use list underscore I as the position to insert this new ID. So I could say list at position list underscore I dot ID is equal to HI ID. Then what do I want to do? I want to say printf, please enter this new person's first name. And I'll use fgets. Fgets what? I just prefer using fgets. Where am I storing this? I'm storing it at list at position list underscore I, right? Because list underscore I is the next available position, store the person's details there. Okay, so please enter this new person's first name. We get it, and we say dot f name. Right, so f gets is equal to list at list position I dot f name. How much was this? This was 25 or 30? 30. 30. And where am I taking it in from? stdin. This is the standard input stream, otherwise known as from the keyboard of the computer. So store the name with fgets. And if it is that you're storing the name with fgets, you have to do your whole list at list underscore I dot f name is equal to, right, f name, sorry, for position strlen for the same, right, -1 is equal to \0. So remove the \n from the text entered. Now you all can use gets. I just like to use fgets. So I entered it with fgets. Okay, we have to do the same for, the person's last name. Right, so store the first name, store the last name. Right, so we put in it in L name. This is L name, this is L name. All right, that's what it was named. L underscore name and F underscore name. Nobody can tell me not have me writing foolishness. That would have given me an error. Okay. Right. So let's check and see. No errors thus far. What's the next set of information we're taking in? The birth date, the birth month, the birth year. All right. These are integers. So we could take it in integers. Please, printf, please, what was that? Please enter this new person's birth date. But nobody can tell me, leave out the prompt for the last name. Okay. Enter this new person's birth date. The date is stored as integers, so we can use scanf. So we could say scanf what? Percent sign D, right? Slash percent sign D slash percent sign D. Right? Let's tell them to put it in D slash month slash year format. Okay. Where do we want to save these? We want to save it at list, at position list underscore I dot what? List at position list underscore I dot. Did I have B underscore day, B underscore month, B underscore year. We have to put the ampersand because it's integers. B underscore day, right, comma, B underscore month, comma, B underscore year. After scanf, you put a get charter, clean up your input stream. So we have enter the first name, enter the last name, enter the birth date. And the last thing that we will do is that we will enter their position. Right? So copy and paste right? Please enter this new person's in position. F gets, so we say F gets list L at position. All right, and we do the same for position dot position. Okay. This getcha was supposed to be after this. Let's see if it works. It seems to be fine. We have it stored. We have it stored inside of the. We have it stored inside of the where you call it, inside of the struct. But if I enter information here and after I'm done, where is this information going to be saved? It needs to be saved into the file. So I have to have a write players file. So void write players function. And this write players function will do just the opposite of the read players, right? Which I should have had a f close fp at the end of. Okay, just because you have to get in the habit of closing your files, Mr. Valdez. So we have to call the write players function. What does the write players function do? It will write the changes to the file. So we're going to write the changes to the file. So now we have to have a void write players function. And if it is, now be careful, and this is where, a little strategy comes in. Copy and paste this, because with opening a file as W, it's going to erase this information. So have a copy so that you could copy this information back in. So, because when you're testing this, if you do the wrong thing, you can lose how much ever information you type up. So we start off by saying file FP. You say FP is equal to fopen. Fopen what? Players.txt. All right, and we opening it for writing. Remember, I told you all that I really only used R and W in my for what we're doing here. We know what append does, but we don't really use append in that manner. I say it's easier to always do read, modify, write. Read, modify, write, rather than trying to do some special thing. And we only have 10 minutes, so I will get it to write to the file, but I will identify a problem that we might encounter when writing to the file that will give us problems reading in the future. Okay? But I don't think we might have time to fix that today. So we will focus on that Wednesday when we meet up in person. So open the file for writing. At this point, the file will be overwritten. It will be emptied, right? The file will be destroyed. But that's okay, because our goal is to write back the information to the file. Okay? We will say write players, right? Write players. Write players. I want to do here list underscore I plus plus, because this move list I to the next position. Right? List underscore I to the next position. You could write code to see if you want to enter another name immediately or whatever, but for now we entering one person at a time. So what do? We have the file open to write. We say int what? Int I And then we'll say for I is equal to 0, is less than list underscore I, semicolon, I plus plus. So for every position, so for every position in the struct array, what do we want to do? For every position in the struct array, we want to write a line of text to the file. So we will say in the same format that we had it written in previously, which was ID, first name, last name, date of birth, and goalkeeper, all separate, and position, all separated by commas. Okay? So we say here, fprintf, right? Or if you want to start it off with a printf so that if you want to start it off with a printf, because whatever printf shows is what fprintf will write. Okay, you could use a printf on the initial just for testing purposes, right? And not have this here just yet. And whatever shows up on the screen will be what writes to the file, so that you don't lose your file as well. We have %d, comma, %s, comma, %s, comma, %d, comma, %d, comma, %d, comma, %s. And you have to put a backslash n here. You might or you mightn't. We'll deal with our backslash n in a little bit. Okay? So display what will write to the file. We're just testing right now. What do we want? What are these positions? This is list at position I dot f underscore name. Sorry, the first one is ID. List at position I dot ID, comma, list at position I dot first name, then list at position I last name, then list at position I D underscore day, B underscore month, B underscore year, and then okay, so we display what we want to write to the file, and the last thing that we'll have to do is close FP. But again, this is just testing right now, so let's see how it goes. We don't seem to have any errors. Let's put a getcha here to pause screen output, right? And let's see if it will write. So when we add in a player, we want to say one, add a player. What's this person's first name? We're going to add Elon. E-I-L-A-N, T-H-O-M-E-S. What's Elon's birthday? Let's just come up with something. The 16th of the 9th, 2004. Okay. And enter Elon's playing position, right? He's a center back. This is what we should see in the file being added if we had written to the file. Okay. But we didn't say write to the file yet, so there is no change to the file as yet. Our file is still as it was. Now we're going to make the changes to say, okay, it looks like it will write. Let's see if we could copy this statement here. And let's see if we could use it as a fprintf. You have to put the file pointer to the front, fp, right? And then we have to close the file. maybe what we could do here, I'm going to take off the test print data. I'm going to put printf, right? File data written successfully. Okay, so that at least we get a positive prompt saying that the data was written. Let's see if we add some, let's try and add Elon again. Now, let's see something there. Oh, I hate how Windows doesn't put this stuff under the taskbar anymore. Yeah. So let's see the file as it is. It does not have Elon's information in it, right? Properties, sorry, open file location. This is the file. We say 1, add a player. Enter this new person's name, A-I-L-E-N. Thomas, 16th of the 8th, 2004. Center back. All right, enter. It says file data written successfully. Okay, notice that because of the fact that I haven't done my F close, this is still reading as 0. But from the time I press enter here, let me see if I could get it to show. Enter, right? It finished writing the data, the file. So I'm seeing that there's 1 kilobyte of data in the file. If I go to my file, Elon has been added. Elon has been added to the file. But there is a problem because I have that hanging new line character, and I don't like that. Because this now will give me problems when I have to read the file in the future. Okay, you see how now problems, I press 2 view all players and my program isn't working as it should. That is because of this here, this hanging indent. So I have to come up with a way to not write data on the last line, of the file, so that I don't put a \n on the last line of the file. I don't have time to do that today. But if I go back to my code, I took off the \n. I believe that everything will run properly if I say view all players. Yes, it does. So next class, we're going to look at manipulating the output file so that it doesn't write a \n on the last line, right? We don't want it writing a \n on the last line when it's writing to the file. And we'll see how we can edit some player data, etc. Any questions? I know that we have 1 minute. Any questions? I think that we had a pretty successful class today. You all find we do plenty towards our SBA. We have almost 200 lines of code written in class today. And actually, if you think about it, we've pretty much met the criteria for the SBA. Read, load into a structure. We have structures, we have arrays, we have file input, we have file output, we have sequence. If you can work this, as we do here, into something useful for yourself, you could have a pretty complete SBA. So we have what is needed for our SBA already. We just want to be better than that. So we have 1 or 2 things that we want to do in terms of editing and searching and deleting. But as far as we see, we have met the criteria for the SBA. Right? Because you can't lose marks because you have everything. You have arrays, you have structs, you have file input, file output, you have functions. We have 6 functions here. So in one class, we pretty much write the SBA. Any questions? People abandon the class or what? Where are we going?
We did.
I stand in front of my code. Yeah. Nobody saying anything?
It's code, sir. What else we could say? Like ones and zeros.
I guess there is nothing to see. I will send this code to you. I'll send it now. I'll send the file that we have to work with now. And all right, oops, that was in compilation. All right, so yes. All right, and that would be it. And we will continue on with this from next class. Okay. People present? People present? People didn't run away screaming or anything, so
No,
I could get a goodbye.
Yes, I had.
Okay. All right. I told you all, I gave you all fair warning that at the end of this class, your head would be hurting. Did I not say it?
Yes.
But this is a good head hurt. This is head hurt because I learned something today. Yeah?
Yes, sir.
Everybody have a good day. All right, God bless. Enjoy your lunch period. I hope that you recover before your next class. Ola, you had something to say?
No, I was saying bye.
Okay, bye-bye. Bye-bye.
Same to you, sir. Take care.
Yeah, bye-bye. Take care.